right? We've seen a similar example to this in our other methods. We are doing our tutors. In fact, we actually just did a tutor one for this method too, for Huntington-Hill. So try this out, really pause, try it on your own before you walk through it with me. I'm going to go ahead and get started, and I'm not going to take a lot of time at the very beginning because our first two steps are the same as every single other method we've had. We take our total population and divide by the number of representatives, in this case, the number of tutors from the total enrollment. 65.7692. That's going to be our starting standard divisor. We use that to find all of our quotas. So 5.474 is from the enrollment divided by the divisor. We're going to do that on all of these. 5.474, 4.029, 2.433, and 1.064. So we get the lower quotas of 5, 4, 2, and 1. Those are just the cutoff values. And that gets us to our geometric mean, which is going to be the square root of 5 times 6. Because this is a 5, it's always that number and 1 above it. The square root of 4 times 5. The square root of 2 times 3. The square root of 1 times 2. We need the actual values of these rounded to 3 or more decimals so that we can compare these values, because that's what their purpose is. That's what our goal is here. So 5.477, 4.472, 2.449, and 1.414. Now we ask the question, looking at the quota, is it lower or higher? If it's lower, we round down. If it's higher, we round up. So lower or higher? Well, this one is lower. It comes down to that third value because we were tied for both of the first two values. So lower, we round down to 5. Lower or higher? 4.0 is lower than 4.4, so we round down to 4. 2.43 is lower than 2.44, so we round down to 2. 1.0 is lower than 1.4, so we round down to 1. This is 12, which is too small. 12 is too small, so we need to decrease the divisor. All right, this is too low, so we need to decrease the divisor. We're going to take that 65.76 and we're going to decrease it to something. A lot of the time, I will lower to the next whole number. So I'm going to try just 65. That's going to be my new divisor. Okay, I'm going to decrease to 65 to try it. I would like you to pause, walk through this whole thing in this chart using the divisor 65, find your quotas, find your lower quotas, geometric means, and then comparing those quotas and means, find your allocation and see if it's right or see if we need to increase or decreasing depending on what it is. All right, I'm going to go ahead and head into it. So 360 divided by 65. 360 divided by 65, because that's my new divisor. 5.538. 4.077, 2.462, 1.077. Those were all of my populations or my enrollments divided by this new divisor. So the lower quotas are the cutoffs. And you'll notice that these are the same lower quotas as our first step. I only bring that up because it might save you a little time. Instead of re-putting all of these geometric means into your calculator, it's going to be the same geometric means because it's the same lower quotas on every single one of them. So I just saved myself some time. I just copied them down because it's still 5 and 6, 4 and 5, 2 and 3, 1 and 2 in our square roots being multiplied. Now comparing again, we have to ask, is it larger, bigger, or smaller? Upper or lower? All right, 5.5, is it bigger? Yes, it's bigger. So we round it up. Bigger or smaller? 4.0 is smaller, so we round it down. Bigger or smaller? 4.46, sorry, 2.46 compared to 2.44 is bigger, so we round it up. 1.0 compared to 1.4 is smaller, so we round it down. So we have 14 now. How many tutors were we allowed to assign? 13. So this is too big. We assigned an extra tutor that the school cannot hire. We now have 14 tutors, which is too many. We need to increase the divisor. 65 was too small. We went from 65.7 to 65. We need to pick something between them. All right, so maybe 65.5, maybe 65.3. I actually picked 65.4, and it's not the only divisor that might work, okay? You have to experiment. Your final divisor, your modified divisor, could be different than someone else's and still work. So I can follow my notes. I picked 65.4 between 65 and 65.7. I picked something that was in the middle-ish. All right, but still relatively easy to type into a calculator. So 360 divided by 65.4 is 5.505. Walking through the rest of our quotas, 4.052, 2.446, and 1.070. So we have our lower quotas, which once again, you'll see that they have the same geometric means as the previous ones. So I'm saving myself time again. They have the same geometric means because it was the same lower quotas. Now we're comparing our geometric means and our quotas once again. 5.505 is bigger. Quota's bigger, we round up. 4.0, quota's smaller, we round down. 2.446, quota's smaller, we round down. 1.0 compared to 1.4, quota's smaller, we round down. 6 plus 4 is 10, 11, 12, 13. So this is our final allocation. We are now to the point where we are done. We have the proper amount of tutors, and that is our other Huntington-Hill example.